So today we're talking about triangles, and we were writing equations based on whether things were supplementary. And what did supplementary mean? Supplementary, 180, 180 degrees. So things added together to equal 180 degrees. And we also had the word complementary. What did complementary mean? Equal to 90. Very good. And so supplementary and complementary, 180 or 90. And if you know those things, they come up all the time in geometry. And so you're going to see that again today. We are talking about triangles today. And I brought some triangles that I cut out. So you can see we have some triangles here. These are rather big for on screen, but I'll show you in just a minute. I brought some visual aids. A triangle is a polygon, so a many-sided figure with 3 sides and 3 angles. 3 sides and 3 angles is a triangle. All right. On the triangle to the left, so on this little example here, the sides of the triangle are, we have this side, which we can call XY. We use capital letters, XY, and we put a segment bar on top. That is a little bar that means the word segment, okay? So segment XY. We have another side, which is right here. It is side YZ. All right, again, capital letters, and it is a segment. So we use a little segment on top. That's what that's called, a segment, a piece of a line. And then what's the last side? XZ. XZ, again, with a segment on top. So segment XZ. So those are the 3 sides. And then we have 3 angles as well. So angle X, angle Y, and angle Z. All right, I cross my Z's so they don't look like 2's. I recommend doing that. Okay, so 3 sides and 3 angles. Very good. Now, it turns out that there's this theorem that tells us, we've got these 3 angles in a triangle, 1, 2, 3 angles in a triangle. And it turns out that they add up to be a very special number. You want to guess what that number is? What? 90? 180. Yeah, like this one here, this triangle right here. What do you think this angle is all by itself? It looks like a right angle, doesn't it? Yeah. So let's see what happens here. So what I'm going to do, I'm going to try. I haven't done this today. Okay. So I'm going to take my visual aid here. I'm going to tear it. I'm going to tear off the corner here. All right. So there's one corner. All right. I'm going to align it right there. There we go. Okay. You see that? Okay. Cool. Here's another triangle corner. All right, so I'm going to tear that one off. All right, put that there. Oh, look at that. Oh, look at that. Oh, I can, God, guys. The tension is, can you feel it? What's it going to be? You think it's going to be underneath? What's it going to be? Oh, look at that. What do you think? Oh my goodness, what is it? What do all 3 corners add up to be? 180. Oh my goodness. Now that was just one triangle. Look at that, they got a nice straight line right there, right? Do you think it'll happen with the other one? Yeah. You think? No. Should we try? You think we should try? Let's try another. All right, here we go. All right, tearing off the corner of this guy, placing him down. All right, there's one. Here comes the other corner. All right, there we go. Oh, ooh. All right, one more to go. Do you think it's going to work? Yeah, let's see. What's it look like? Oh, that's pretty good. Oh my, okay, ladies and gentlemen, what does the triangle sum theorem tell us? All the angles add up to be 180 degrees. Very good, ladies and gentlemen. We just proved the triangle sum theorem. Amazing. 180 degrees comes up all over the place. It's kind of nice, you know. We don't have a ton of things to memorize. 180 sounds pretty good to me, right? So the angle sum theorem states that the sum of the measures of the three angles is always 180 degrees. All right, so question, if angle Y is 60 degrees and angle X is 40 degrees, what is angle Z going to be? How did you get 80?
The 60 plus 40 is 100.
Yeah, good. 60 and 40 makes 100. So we're 80 degrees away to create that. So it doesn't look like 80 degrees though. No, but that's okay. So we're pretending it. All right, so all three angles of a triangle always add up to be 180 degrees. So we have this little statement we can say, the measure of angle X plus the measure of angle Y plus the measure of angle Z is always going to equal 180 degrees. And so our job today, again, is writing equations, just like we've been doing. You guys are pros at this now. And so here I have a lovely triangle. We want to find the missing measure. And so, again, we can do this a couple of different ways. But I know that all three angles should add up to be 180. So X plus 79 plus 82 should equal 180 degrees. Can we clean that up? We can combine the 79 and the 82, and what do you get? 161, good, very good. X plus 161 equals 180. And then what do we need to do? Subtract, good. Subtract 161 from both sides, so we get X equals 19 degrees, very good. Could you have done that on the calculator?
Yeah.
Pretty easy, right? Could we have just done like, hey, this is just going to be 180 degrees minus the 79 minus the 82 on the calculator, and that's going to give me X. That's pretty nice, right? Okay, so sometimes you have two options. You can just use the calculator if it's all numbers. Okay, ladies and gentlemen, here you go. Will you grab your calculators? Grab your calculators and figure out number 2. Do it now. Do it now. 63, yes, X equals 63. How'd you get that? Subtract from 180. 180 minus 68 minus 49. Good. Ladies and gentlemen, tell me about number 3 here. 90 degrees. You know it's 90 degrees. Will you solve number 3, please? Figure out X. 37. Very good. 37. Number 4.
119.
119. Holy cow, you guys are rolling. All right. Do 5 and 6 real fast. Actually, you can do 7 too. 5, 6, and 7. Do it now. All right, I'll give you guys a second. Everybody's got 5 and 6. Good. Hang on. 7. All right. What'd you get for 5? 69 degrees. What'd you get for 6? 71 degrees. Beautiful. Okay. Let's see. What did you find first on number 7? 2? I heard 2 and 3. So 2, how did you know 2 was 48 degrees? Because they're vertical angles. Very good. That's right. These are vertical angles, and we know they're congruent to each other. So angle 2 is 48 degrees. And then I heard angle 3. How did you figure out angle 3?
I added 49, 48, and 90.
Okay, because we knew that right angle there, so 90 degrees. So 180 minus 48 and minus the 90. So angle 3 turned out to be? 42. You got to subtract from 180. Yep, so 42 for angle 3. Okay, and then how do we figure out angle 1? Yeah, so again, 1, 2, 3 angles in a triangle. So we got a couple of ways we can do it. 180 and just subtract the other 2 angles. Minus 67 minus 48. And so angle 1 turned out to be 65. Beautiful. Okay, great. So when we just have numbers, is it super easy? Yeah. Super easy, okay? So when we just have numbers, oh, look at number 8, ladies and gentlemen, number 8. Do we just have plain old numbers? No, we have algebra, okay? So now we have a triangle, and 1, 2, 3 angles all need to add together to equal what? 180. So what equation can I write down? All of them added together, sure. Let's see. 4x plus, oh, whoops, daisy. 4x minus 5 plus 5x plus 1. 5x plus 1. Do I need the parentheses? No, I don't. Plus 14x's equals 180 degrees because the angles in a triangle always equal 180. All right, now what can we do? Combine like terms. 4x's plus 5x's plus 14x's is 23x's. And then we also have a negative 5, a positive 1. Who wins? Negatives by 4. Very good. So we have 23x minus 4 equals 180 degrees. And then what should we do? Add the 4 to both sides. So we get 23x equals 184. And then divide by 23. Divide by 23. So we get x equals 8. Very good, you guys. Beautiful. Okay, so just like we were doing, we're writing equations of things. So turn the page. Let's do number 9. Now this one says find the value of x. So that's what we just did. How are we going to find the value of x? Add them all up, and they should equal 180. Very good. All right. So 6x minus 7 plus 3x plus 4 plus 9x minus 15 equals 180. Let's see. What do we do? Combine like terms. You guys are awesome. Have I told you lately how awesome you are? No. You guys are awesome. Let's see. 6x's plus 3x's plus 9x's is 18x's. Very good. And negative 7 and a positive 4 and a negative 15. Ooh, that's a whole lot of negatives. 18, I believe so, and they're negative, right? Because we've got more of those. So negative 18 equals 180. Very good. And then what do? Add 18 to both sides. We get 18x equals 198. And then divide by 18. Divide by 18. We get x equals 11. All right, beautiful. Are we done? No. What do they want us to do? Find the actual angle measures. This is just the value of x. It's not actually the degrees. So we need to take the value of x and we have to plug it in to each of these. So I'm going to go here, and in my calculator, I just get to do 6 times 11 minus 7. So I'm plugging in my 11. Will you do that in your calculators, please? What do you get for that? 59. 59. So that is 59. And again, I much prefer you to just write right on your picture. I think that's the best way. Go right back to where you were. Over here for angle B, we're going to do 3. Plug in the 11 plus the 4. Use your calculator. 33 plus 4 is 37. And then see, so 9 times 11 minus the 50. Oh, I hate subtraction. It's so much harder. Okay. And we get 84. Good. All right. So 84 degrees. So there we go. 84 degrees. So sometimes you just have to solve for x, and sometimes we want you to plug it back in. Fantastic. Give me a thumbs up. You understand the triangle sum theorem? All right. Very good. That's a key part of geometry. All right. You guys just learned like a whole semester of stuff right now. That's amazing. Okay. Really, really cool. So we also want to be able to classify triangles, different types of triangles, which again, you guys already know this. Classifying by angles. We can draw a triangle that has all acute angles. What does acute mean? Less than 90 degrees. Very good. So all 3 angles are small little angles. So something like this is an acute triangle. And we call it a cutie pie because all the angles are small little baby cuties. Just like this triangle right here is an example of an acute triangle, okay? We can draw a triangle that has one obtuse angle. What is obtuse? Greater than 90, so greater than 90 degrees. So this would have a fat angle like this one here. So this is a nice fat angle. It's maybe 120 degrees. And then I can connect the top. And you can see these little angles have to be kind of small, right? Can you ever have more than one obtuse angle? Can you have 2 obtuse angles? No, why not? Yeah, if I have 2 obtuse angles, 2 angles that are bigger than 90, so 95 and 95. What is 95 and 95? What is it? 190. 190 I think is right because 180 plus 10 more. Yeah, 190. Good. And 190 is too much, right? It's bigger than the 180 degrees. So we can only ever have one obtuse angle. So maybe this is like 110 degrees. All right. And so only one can be bigger than 90 degrees. We can also have a triangle like this one, which has how many right angles? One right angle. So one right angle, maybe I can draw one right angle right here. And the legs can be different lengths, but one right angle, again, we have one 90-degree angle. Can there be 2 90-degree angles? No, again, that's too much. We'd already used up all of our degrees on just 2 angles. Where's the third one? All right, it's like in some weird black hole. All right, doesn't matter. All right, so we can have a right triangle which has one right angle. Beautiful. So then, those we can classify by angles. We can also classify our triangles by the sides. When there are no congruent sides. So I'm going to draw a triangle that has 3 different side lengths. So maybe this is like a 4, a 6, and a 7. That could be a potential triangle where all 3 side lengths are maybe 4 inches, 6 inches, and 7 inches. They're all different. This is called scalene. A scalene triangle. Scalene means different side lengths. Okay, all 3 sides are different. 2 congruent sides. 2 sides of my triangle match. Congruent, they are the same. Maybe if this side is 7 inches, what's the other side? Also 7 inches. I don't know what the third side is, but it's different than the 7. So maybe it's like 11. I don't know. But here, 2 congruent sides. This is called, does anyone know? 2 congruent sides? Starts with an I. Very good. Isosceles. 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 Isosceles, two congruent sides. There are two congruent sides and a different side. If we have three congruent sides, that's a very special triangle. 1, 2, 3 congruent sides. Maybe they're all 5 centimeters, 5 centimeters, 5 centimeters. They're all three sides are congruent. Equilateral, very good. Equulateral. Lateral is the Latin for side. And so like doctors, they'll make a lateral incision. That's a incision on your side, right? A lateral incision. So equilateral is equal sides. 3 equal sides. And it turns out if there's 3 equal sides, all these angles are going to be the same too. Because if you have equal sides, you'll also have equal angles. So all of these angles turn out to be 60, 60, 60. Why 60 degrees? Because 60 times 3 is 180. Very good. 60 times 3 is 180. Perfect. All right, we want to classify each triangle by its angles and sides. All right, we have one right angle and we have 2 congruent sides. What would you call this triangle? Isosceles? Isosceles? Right. Very good. Isosceles right triangle. And we often just draw a little triangle to represent the word triangle. That is very common. All right, this is isosceles right triangle. Number 11 here. It is equilateral. And tell me about all 3 angle measures. They're all the same. They're all little cuties. So we could call this equilateral. Acute. I also want to say because and I don't know if this word comes up, when all 3 angles match, you might see the word like EQUI, angular, equiangular. I don't know if that's going to come up in Delta Math or not. Will you write that down, please, just so if you see it? Equiangular. What do you suppose equiangular means? Equal angles. Yeah, equal angles. All 3 angles are exactly the same 60 degrees, okay? So equilateral, equiangular is a word that might come up for classification. I don't know. Let's look at number 12. Scalene. Oh, how did you get obtuse? Angle. So you found the missing angle? How do we figure out what that measure of that angle is? Subtract from 180. So 180 minus 41 minus 22, and we get 111, 117. All right, so this, tell me about the 3 sides. Are they the same or different? Different. So that is scalene. S-C-A-L-E-N-E. Scalene. And it has 1 obtuse angle. So scalene obtuse. So it has 1 fat angle. So it's obtuse and scalene. All the sides are different lengths. Number 13. Yeah, isosceles. We have 2 congruent sides. So we have isosceles triangle. And can we figure out the 3rd angle? What is the 3rd angle? 36 is right. 36. Yeah, so tell me about all 3 angles. They are acute. Very good. All 3 angles are less than 90 degrees. Very good. And then let's see. Let's do number 15. What's our 3rd angle going to be? 110. Is it 110?
It's 90.
It's 90. 90, yeah. So it's 90 degrees. 180 minus 56 minus 34. We get a 90 degree angle. all three angles are different, which also means all three sides are different. So this, all three sides are different. It's going to be scalene right because it has one right angle. This is a scalene right triangle. All right, ladies and gentlemen, do you have any questions for me? Cool. All right. You guys have a Delta math today.